welcome to this video. Now in this one I've got a very good question from June 2018 paper 2 pure from A-level maths Edexcel, and this is one of the very much requested questions by my students, as a lot of them have struggled to do this question, especially part B, and some of them have struggled with part C as well. So let's go ahead and try this question out. I will be walking through each and every stage properly so that you can hopefully understand this better. Obviously, with this question, there might be more than just one method. So if you do have another method for part B than the one that I'm going to do, please feel free to share with me. So let's get started. So it says a scientist is studying a population of mice on an island. The number of mice n, with the n in the population, t months after the start of the study, is modeled by this equation right here, where t is greater than or equal to 0. And we need to find out the number of mice in the population at the start of the study. So that's really easy. When t is equal to 0, we can figure out the value of n. So n is equal to 900 over 3 plus 7 e to the power of 0. Anything to the power of 0 is 1. So it ends up giving you 900 over 10, or just 90. Okay, so for the next part now, it says show that the rate of growth dn over dt is given to you by this equation. So let's start off with, first of all, writing down the equation. So we have, for part B, n is equal to 900 over 3 plus 7e to the power of minus 0.25t. Now, a lot of people will try this using quotient rule. I am just gonna bring this denominator up just because 900 is a constant. I'm just going to use chain rule. Okay, now obviously feel free to use quotient rule over here if you want. It would give you the same result in the end. So I'm just going to do it slightly shorter way. That's to my liking. Okay, so we have n equals that, therefore. Okay, and now I'm just going to use differentiation by chain rule. Okay, so dn over dt is therefore equal to 900 times by minus 1 times by 3 plus 7 e to the power of minus 0.25t to the power of minus 2. Okay, I'm going to run out of space. And then I'm going to differentiate what's inside, okay, the brackets. So I've differentiated the main function, which is with respect to the power, and now I'm going to differentiate this bit right here. Now, differentiation of 3 is, of course, 0, and differentiation of 7 times by minus 0.25 e to the power of minus 0.25 t. Okay, so that is your differentiation of the main inner function right there. Okay, and now I'm going to try and tidy this up, and let's see how that goes. Okay, so we have the minus 900. I'm going to bring this bit down in the denominator, and that will be 3 plus 7 e to the power of minus 0.25 t squared. And then I have the numerator with minus and minus actually makes it plus, so 900 times 7 times a 0.25, which I guess I can write it down as a quarter, so a 4 at the bottom. Okay, so, and then I've got my e to the power of minus 0.25t. Okay, so that's basically as tidy as it would get for now. Okay, now, this is obviously not the answer. Okay, if this was the answer, it would have been very, very simple question, and hence I wouldn't be doing it. So for the next steps now, the aim is to get rid of e to the power of minus 0.25t, okay, and make sort of n or in terms of n, I need to introduce n into my equation. So what I'm thinking of is using this as my main equation, okay, and working around it. So what I mean by that is basically that if I notice that there's a 900, okay, in this equation, and I also notice that there is a 3 plus 7 e to the minus 0.25t twice, okay, I'm just going to break this down into two sort of different denominators. Of course, they're multiplied together, okay, just to simplify it so that you are able to see how I can reintroduce the value of n back in, right? So because now we know that this function over here is equal to n, I can simply replace it by n, okay? So that just disappears, okay, into n. Now, the rest remains the same so far, so let's just put it back there. Now I have to, the next step is to get rid of the, in no particular order, get rid of either the 7e to the power of minus 0.25t or the thing in the denominator. So what I'll do is I'll further break this up clearly so that you can see what's going on. So I'm gonna just put this on the side here and put 8 times in the middle. Okay, so I've got 1 over, in fact, I'm just gonna also put the 4 on the side. Right, so now I've got this in the denominator. Okay, now what do I further notice? Well, I notice that in my main equation highlighted in yellow, that 3 plus 7 e to the power of minus 0.25t is also in the denominator, right? So if I just bring that right here and manipulate it slightly, I can say that if I divide both the sides by 900, then I would end up getting 3 plus 7 e to the minus 0.25t, exactly the way I like, okay, exactly the way I want. So this means that I can now replace, let's use another color, I can now replace this by this, okay. I replaced earlier 900 over the 3 plus 7 e to the minus 0.25t by n, okay, and now I'm going to replace my second fraction by n over 900. I hope that's making sense, okay? I'm just basically doing it step by step so that you can see it through, but all I'm doing is just making or reintroducing n in some form or the other as per the question is asking, okay? So let's now rewrite this, okay? So far we now know that dn over dt is equal to n times n over 900, okay? And then I have, of course, this last bit that I have to deal with, okay? So right there. So now I have to make 7 times e to the power of minus 0.25t the subject, again from the main equation, okay? So let's do that. So I'm just gonna highlight that yet in another different color so I can see that that's there, okay? And I can see that that is also right there, okay? So let's rewrite this initial equation, the main equation. So n is equal to 900 over 3 plus 7 e to the minus 0.25t. Okay, now from here I'm gonna divide both the sides by n and multiply both the sides by the denominator, so it becomes like so. And now from here I have to simply take away 3 so that I have 900 over n minus 3. Okay, so there we have our 7, okay, e to the power of minus 0.25t as in terms of n, right? So now I'm going to put that into there, basically. Okay, so we've got dn over dt, therefore, equal to n times n over 900 times by, I'm going to just keep the quarter right there, and then 900 over n minus 3. Okay, so now everything is in terms of n and a few numbers. So now is the point where I'm going to just simplify this, okay, tad bit. So keeping an eye out on what I need, okay, I'm just gonna bring this bit. Let's see if I can bring this here. Okay, so now I know what I need to do. So dn over dt, therefore, is n squared over 3600, okay, and then 900 minus 3n over n, okay, so n and n cancels out. I have a factor of 3 that I can take out, so 3n brackets 300 minus n over 3600, and 3 goes into 3600 1200 times. So there we have our final answer. Okay, so it is really not fair for the number of marks. I believe it's what, for 4, yep, 4 marks, okay. Kind of really unfair, okay, because the number of steps you have to take, I mean, I would feel that this is unfair to me, because if I was to do this in the exam, it will take me a little bit longer than just 4 minutes to get this done, right? So I appreciate that this wasn't a very easy question, but even more of a reason to do questions like this. Okay, so let's move on to the next part now. With part C, it says that the rate of growth is maximum after t months. That means that, oh, hello, what happened there? Let's just move it, okay, there, okay. So the rate of growth, which means dn over dt, is max, okay. And we need to find out the value of time t, okay, based on this equation. Okay, so let's go back here. And what I would do is plot a graph, okay. Now, make sure you know that they're talking about the rate of growth, okay, not the number of mice, okay, but the rate of growth is maximum. So this is where a lot of students may have gotten wrong, where they would have drawn a graph, or they would have differentiated twice. It's much easier than that, okay, so I would just simply draw a graph, okay, so dn over dt versus n, okay. So according to this equation, I know that it's going to be a quadratic graph, okay, and I know that it would pass through the origin, and it would look something like this, okay. You can obviously use a calculator, graphical calculator, to get this, but it shouldn't be that hard to obtain a graph like this, a sketch like this on your own. So it would be like this, and this point right here, okay, would be 300, and due to symmetry, this value over here will be 150, okay, the maximum. So the growth is maximum, okay, the rate of growth is max at n equals 150. Okay, so from here now, I would work out the value of t. Okay, so now I know, right, that I was given n as 900 over 3 plus 7 e to the minus 0.25 t. Okay, so from here now, I would introduce 150, divide both the sides by, or rather, just basically move this here first, 900 over 150, and then I am going to simply, I can do it in as many steps as I want, okay, so I can now take away 3 from both the sides, so this is 6, and then take away 3 and basically divide by 7, so right here, or just 3/7, okay. So now what I have is, if I lin both sides, okay, so this is that, let's just bring it here, so now ln both the sides, that will be minus 0.25t equals ln of 3 over 7. And ln of 3 over 7 turns out to be minus 0.847 something something something. And now I'm going to just divide both the sides by minus 0.25, and that shall give me a value of 3.39, okay, months, and we can round this to 3.4 months, okay, and that would be basically our answer right here. Okay, so I hope that makes sense. Now let's move on to our next part of the question, which is, now this is definitely worth 4 marks, right? Because this is rather simpler. One thing I would say is that even if you didn't do part B, you still could do part C. Okay, so it's not the end of the world, okay, if you miss out 4 marks. Obviously every mark counts, okay, every little helps, but it's, again, you should still try the subsequent parts, because you never know, you might be able to do them really well. Okay, so for the last part now, we are given that according to the model, the maximum number of mice on the island is P, and we need to state the value of P. Okay, well, that's easy peasy, okay, because maximum is when t tends to infinity. Okay, so when t is a very large value, so let's put that down over here. So we know that n is equal to 900, and 3 plus 7 e to the power of minus 0.25t, and as t tends to infinity, okay, you can put any value, any large value of t, and you'd end up getting n as, well, 300. Okay, so that's basically the answer there. Quite simple. Okay, so this is it for now. Okay, and I hope you found this walkthrough useful, and let me know in the comments below if you do have any questions or you would like to share another method. I'd be more than happy to discuss that. Thanks ever so much for watching, and I'll look forward to seeing you guys again in my next video.